Hi, this is going to be part of a four-part video series where we are going to um, compute the volume of this region here, bounded by the x-axis, x equals 1, x equals 3, and y equals 3 to the ex, um, rotated around either the x-axis or the y-axis. And we are going to show two different methods for each computation, um, which will give us a number of different ways to approach different versions of this problem. So, start off with, we have our initial situation, but there is some additional information that would be useful to fill in for not just this part of the problem, but for all the upcoming parts of the problem. So, one thing to note is that while this curve here can be thought of as the curve y equals 3e to the x, the same curve can also be thought of as um, x is the log, of y over 3. And if you want to see where that computation comes from, we can divide both sides by y equals by 3. And then by taking log of both sides, we get this equality. So this is the same curve as that. And this will be useful if we want to think of these values as either y values or x values. Now, uh, for the first part of this problem, we are going to compute the volume of the solid generated if we rotate this region about the x-axis. So it'll come down here and it'll form like a little disk thing like that. And so what we want to note is that for an arbitrary x in this region, let me maybe switch a different color. For an arbitrary x, that height there is going to be y equals 3e to the x. So the radius of a circle generated by that is going to be y equals 3e to the x. So one way we could generate this this volume is through the disk or washer method, in this case just the disk. And we could say that this volume is going to be equal to, it's going to be some definite integral. The areas of my cross sections are going to be pi times the radius squared. This is with respect to x. My y values range from 1 to 3. And so that generates an integral which computes this volume. All right. Thank you very much. I'll see you in part 2 of this video series.